What I have for you today is a self-help video on stoichiometry, mole to mole, mole to mass, mass to mole, and mass to mass. For all the problems, we're going to be using the following reaction. Ethane reacts with oxygen to produce carbon dioxide and water. The balance equation is already provided for you, and on top of that, just to make it easier, I went ahead and provided the molar masses for all the compounds that are given because we're going to be using them. Okay, so if you notice, here's ethane, C2H6, molar mass is 30.08, carbon dioxide 44.01, oxygen 32, and water 18.02, and they're all grams per mole. Okay, so we're going to start by doing a mole-to-mole problem. Okay, that is how you solve it, but the question is, how do we get to that point? Okay, so we start out with the question. It's how many moles of ethane are needed to produce 12.33 moles of water? So I guess the first question should be, how do I know it's a mole-to-mole problem? My given, which is right here, is moles. And then they want me to find moles again. So that's what they want me to find, and that's how I know that it's moles to finding moles, so mole-to-mole problem. Okay, in a mole-to-mole problem, it's the shortest of them all. So you're actually going to have just 4 little boxes, with the one underneath the given always being blank. So you start off with your given. Your given is 12.33 moles of water. Okay, I'm going to tell you that whenever you start with moles, the next step is going to be one that has moles on top and moles on the bottom. Not only that, but our given also tells us what we're going to write diagonally. So if this says moles of H2O, this has to say moles of H2O, or whatever yours says. So if yours says moles of carbon dioxide, then this would be moles of carbon dioxide. Keep in mind that I just finished saying that if you start with moles in the given, that means the next 2 steps, or the next top and bottom step, has moles on top and moles on the bottom. For the compound, it's going to be the other compound that's being asked for. So in this case, they're asking for ethane, C2H6. Okay, so right in front of it, we're going to go ahead and write the numbers. Whenever you have moles and moles as your step, moles on top, moles on the bottom, you're going to be using the coefficients. So C2H6, the coefficient for that one is 2. So you're going to put a 2 right in the front. And then for water, H2O, the coefficient is 6. And that's why we'll write a 6. Okay, from this point on, you're going to go ahead and multiply 12.33 times 2. You're going to multiply across. Okay, that's going to give us 24.66. Okay, there's nothing to multiply with that 6, so you just carry it across, and it's 6. Okay, you divide the top number by the bottom number. That's going to give us a grand total of 4.11. Okay, as far as the units we use, we cancel moles with moles of H2O, and we're left with moles of ethane. So that's going to be our moles, or our unit, sorry, that we leave off for our answer. So moles of C2H6. Okay, on the next problem, it's going to be a mole to mass. And how do we know? Again, we look at our given. Our given is moles, and they want us to find grams, and grams is always mass. So this is a mole to mass problem. So this one is a little bit longer than the mole to mole, so it's going to require you to have 6 little boxes. 3 on the top, 3 on the bottom, with the one underneath the given never being used. So you always start with the given. Our given is 3.50 moles of O2. Okay, we're starting with moles. Like I said in the last The last example, if you have moles, that means that this next step will have moles on the top and moles on the bottom. All right, so whatever this compound is has to be diagonally the same here. Whenever you have moles and moles, the compounds have to be different. They cannot be O2 on both sides, or on both top and bottom. So you're going to use the other compound that's being asked for. In this case, it's asking for grams of carbon dioxide. So our formula for carbon dioxide is CO2. Okay, once again, when you have moles over moles, you're going to be using the coefficients that are in the balanced equation. So for CO2, it's 4, and for O2, it's a 7. Okay, and this allows us to cancel moles of O2 with moles of O2. Okay, whenever you have a step that's moles over moles, that means these next two will have grams and moles. Now you might be asking, how do I know if grams goes here or grams goes here? How does that happen? Well, keep in mind that you always have to write this diagonally. Whatever this says as your unit and your compound, you have to copy it down here. So this is going to be moles of CO2. Okay, and this will be the grams of the same compound. Notice that again, when it's moles and moles, the compounds are different. When it's grams and moles, the compounds are going to be the same. Okay, as far as the compound or the number that goes in front of moles when it's grams and moles, moles are always going to be 1. Because our molar masses are grams per mole. And that's exactly what you're doing. You're doing, this is your grams and this is your per mole. Okay, so we're going to get the molar mass of CO2. If you recall, the molar mass is 44.01 grams per mole. Okay, so in this event, we're going to go ahead and multiply across. 3.50 times 4 times 44.01. Okay, that gives us 616.14. Okay, 7 times 1, that's 7. So now you're going to take the top number and divide by the bottom number, and that's going to give us a grand total of 88.02. And we need the unit, so I'm going to cancel the moles of CO2 with the moles of CO2, and I'm left with grams of CO2. Your unit is always going to be whatever it is on the very last box at the top and alongside with the compound. Otherwise, take a look at your question, which is asking how many grams of carbon dioxide, and that's exactly what you should be answering, grams of carbon dioxide. For our next problem, it's a mass to mole problem. So in this one, just like the mole to mass, you're going to have 6 total boxes, 3 on the top, 3 on the bottom. You always start with your given like you do with every single one. So it's 150.23 grams of water, 150.23 grams H2O. Okay. Whenever you start with your given as grams, that means that this next step is going to be grams and moles. To decide what goes here, remember that you're going to put this diagonally. So this is grams of H2O. And as I said in the last example, grams always goes per 1 mole because it's grams per mole of the same substance. Okay, here's going to be the molar mass of water. So if we look back, molar mass of water, 18.02. All right, at this point, we get to cancel grams of H2O. Okay, so we're going to alternate. Since we had a grams and moles problem or step, that means our next step over here will be moles over moles. Because once again, they alternate or take turns. All right, so this is going to be canceled diagonally, so it has to be of H2O. And moles cannot be of the same compound. It has to be different. Grams and moles will have the same compound, just like you see here, but moles and moles will always be different. So what do we need to put here? What compound? It's got to be the one that they're asking you to find. So they're asking for how many moles of oxygen. So it's oxygen. Okay, just like I said before, when you have moles on top and moles on the bottom, the numbers that go here are the coefficients. So oxygen is 7, so I would put a 7, and water is 6. So we put a 6. Okay, so I'm going to go ahead and multiply across 150.23 times 1 times 7, and that's going to give us 1,051.61. Same thing with the bottom, 18.02 times 6. That's going to give us 9.73. Okay, finally divide the top by the bottom, and it's going to give us 9.73. Okay, don't forget NUC, number, unit, compound. So we have the number, we need the unit, and we need the compound. So I'm going to go ahead and cancel moles with moles of H2O, and we're left with moles of O2, which is what our answer should be, moles of O2. So did we answer the question? How many moles of oxygen? Yes, 9.73 moles of oxygen. Okay, our last example is a mass to mass. Mass to mass is the one that has a little bit more steps than the rest. It just has one more to where you have 4 boxes on the top and 4 on the bottom, just like this. You're going to start like any other of the examples that we did on stoichiometry with the given. So 25.60 grams of oxygen, just because it says it here. Okay, so we're starting with grams. So remember what I said, that when you start with grams, that means this step will have moles and grams. Okay, so we're going to go ahead and decide that the bottom one will be grams and the top will be 1 mole. And that's because this has to cancel diagonally. So this is grams of O2, and again, that's where the molar mass of O2 will be, and this will be 1 mole of the same substance, O2. Okay, that allows us to cancel these guys. All right, so molar mass of O2, 32 grams per mole. Okay, so again, alternating, since we used moles and grams, that means the next step will be moles and moles. And if you just want to kind of skip ahead, we know that this step, because this is moles to moles, will be moles and grams, with moles being on the bottom just because it's going to have to cancel, and grams being on the top. So remember, alternating moles and grams, moles and moles, and then here grams and moles. Okay, so this has to be the same diagonally. So this is going to be moles of O2. This has got to be a different compound, and it's got to be the one that they're asking us to find. And the question is, how many grams of ethane? So that's going to be ethane, C2H6. All right, so here, whenever you have moles over moles, you're going to be using the coefficients. So we know that ethane is 2, and we know that oxygen is 7. Okay, now we can cancel moles of O2 with moles of O2, and we're left with moles of ethane. And we had already decided that this is a order where we're going to have grams over moles so that moles could cancel, but now we need the compound, so it's going to be moles of C2H6, and this will be the same substance because grams and moles always has the same substance. Moles and moles has a different substance. Here's grams and moles, same substance. Okay, with grams and moles, don't forget it's always per 1 mole. So you're going to put the 1, and then the grams is going to be the molar mass of ethane. So in this case, 30.08. Okay, so now you're going to multiply across 25.60 times 1 times 2 times 30.08. Okay, in this case, it's going to give us a grand total of 1,540.10. You're going to do the same with the bottom, 32 times 7 times 1. That gives us 224. Okay, so now you got to divide the top by the bottom. Once you do that, that gives us 6.88. Okay, as far as the units, we cancel. So this cancels with this because they're the same. And we're left with grams of ethane. So 6.88 grams of C2H6. And then if we look at the question, it's how many grams of ethane, and we're answering with grams of ethane, 6.88 grams of C2H6.